Konnichiwa guys. Let's study about RBC. We should know its dimension. It is 7 micrometer in length and 2 micrometer in breadth, whereas thickness, and its volume is asked. Volume is 87 micrometer cube, whereas surface area is 140 micrometer square. Volume is 87, surface area is 140. 87 and 140. Why is biconcave? Why has God made RBC biconcave? Now, advantage of biconcavity of red blood cells when it is exposed to hypotonic environment. Hypotonic environment, you know what it means. Means in the environment in which they are, sodium is lessened. The sodium or any solvent or something like that is lessened. Solute, is lessened as compared to the it is less. So water moves from the environment having more. So more solute moves from environment having less solute to the more solute. So in hypotonic condition, it swells. It increases the rate of exchange and folding of a it helps in squeezing through the capillaries. Now red blood cell composition, we should know this. In males it is 5 to 6 million per cubic millimeter. Cubic meter. Whereas in female, in male it's like 4.5 to 6. Whereas in females it is like 4 to 5 million per millimeter cube. In newborn it is like 6 to 8 millimillion. Children is like 3 to 5. In children is 3 to 5. Females is 4 to 5. Males is 5 to 6. And it's highest in the newborn, like 6 to 8 million per cubic millimeter. Radioactive chromium is lifespan of RBC is measured using radioactive chromium. Now abnormal size, normal size, micro, macro. Less than 87 is micro, more than is macro. Then hypochromic means decrease in hemoglobin concentration as seen as iron deficiency. Based on shape, they can be of lotosphere, elliptic, or coicular size, different shapes, right? Then this is microside, this is macroside, this is an isoside, spherocyte. This is basophilic. happens when basophilic granules are present in red cells. This condition is called punctate basophilia. It is typically seen in lead or other heavy metal. It is seen in lead or other heavy metal poisoning. Also seen in thalassemia, megaloblastic anemia, liver infections. Then target cell is seen in obstructive jaundice, liver disease, and stomatocytes. They again seen in alcoholism, liver disease, jaundice, whereas this is in this heavy metal poisoning. Sickle-shaped red cells are called drepanocyte. It can be asked. Drepanocyte. Sickle-shaped cells are called drepanocytes. When is Rolex formation seen? It is seen in increased gamma globulin increased and erythrocyte sedimentation rate is high. Now, packed cell volume is basically the amount of volume occupied by the RBCs in the blood upon centrifugation. So, we should know strong value. Adult male is 46, whereas female is 42%. 46-42. Then we studied 87 and 140 back in previous video. Volume and surface area. Now erythrocyte sedimentation rate. It is rate at which the red cells fall or form Rolex. Now the factors can be shape, mass, size, plasma factors like fibrinogen. Erythrocyte sedimentation rate, venue, factors, shape, size, plasma factor, and other factors like temperature and viscosity. Now the normal values of ESR are values of ESR are measured using two methods, using two types of tube, Winthrop and Westergren method. In Winthrop and this is the Winthrop tube. It is shorter and has one open end. So Winthrop tube is used for both ESR and packed cell volume, whereas Westergren tube is used strictly for ESR. Okay, the anticoagulant used. It is an important question. Anticoagulant used in Western world is sodium citrate, whereas in Winthrop it is EDTA or oxalate, double oxalate. It is open at both ends. It's open only at one end. It is 110 mm length and it is 300 mm length. It is strictly for ESR. It is for both ESR and PCV. standard method and we use sodium citrate, whereas Winthrop uses EDTA. Now physiological variation, pathological variation. ESR basically increases in pregnancy, in menstrual bleeding, gender, age. ESR is more in newborns and infant. Think of it: age, gender, pregnancy, menstruation. Okay. Now pathological variation, increase and one more physiological variation. ESR decreases at high altitude. Now pathological variation, increase in ESR can be bone marrow cancer, arthritis, tuberculosis, sickle cell disease, and this is a very important point, that ESR increases in all types of anemias except in membrane-based hereditary diseases like hereditary spherocytosis, then sickle cell anemia, and it also occurs arthritis, anemias except spherocytosis, sickle cell, decrease in polycythemia, sickle cell anemia. It decreases in sickle cell anemia and spherocytosis and polycythemia. You can remember that ESR decreases when there is polycythemia. Polycythemia is increased RBC cell production. So, because of that, ESR decreases. Because clumping is overcome by the amount of RBC cell repulsion to each other. And then hypofibrinogenemia, spherocytosis, sickle cell anemia, hypofibrinogenemia. Then there is polycythemia.